Hello everyone. Today we are going to discuss serial communication standards which are used for data transfer from microcontrollers to personal computers. The objectives of today's sessions are: first is to study RS-232 standard for serial communication. Then second we will see USART protocol of PIC microcontroller, universal synchronous asynchronous receiver transmitter. This particular mode that is allotted for PIC microcontroller that we will study. Second, we will see the calculation for desired baud rate calculation, and in the final stage we will see circuit diagram of interfacing MAX232 IC with PIC microcontroller for serial communication data transfer. So let's start with the session. All of you know that microcontrollers are parallel devices which uses port pins for data transfer in parallel form, because our microcontrollers are 8-bit, 16-bit, 32-bit. So these 8 pins which are allocated for ports are used to do data transfer operation in parallel form with IO devices. We can carry out we always carry out data transfer from these ports in parallel form with input output devices, from microcontroller to output device or from input device to microcontroller. So generally we perform data transfer in parallel form, but if we look at for a longer distance communication, then parallel communication is quite expensive. We cannot go for parallel communication because we require 8 wires for data transfer operation, which increases the cost of the infrastructure. Along with this, this system will become very expensive. So to avoid this, we will use, or Electronic Industries Association has developed standard for allowing compatibility in between the communication devices to have data transfer in serial manner. Though this serial communication standards was developed quite long before the invention of microcontrollers, these serial communication devices are used with the microcontroller for serial communication data transfer. Now, what this serial communication are? Serial communications uses only one wire for the data transfer, and over a single wire we can transmit data in serial bit manner. That means one bit at a time only. So there are ways to have data transfer in between two electronic devices in various modes. Okay, these communication links, we can say that simplex communication link. There are three types of data transfer: simplex, half duplex, and full duplex. Simplex communication is nothing but only one way transfer we can have in serial form or in serial manner. That means only transmitter will send data from transmitter to receiver, single bit at a time. In half duplex communication, we can transfer in both ways, but one operation at once only. That means we can either transmit or either we can receive the data in serial manner from in between transmitter and receiver. And third, and which is the last one, that is full duplex communication, in which we can do data transfer operation from transmitter receiver at a time. So single bit data transmission will take place at a time. So here two wires will be used for serial communication. So one will transmit and second will receive. So two pins are required to have data transfer in between electronic devices. Now, as per the clock use or as per the configuration, there are two types of serial data communication. One is synchronous serial data communication, and second is asynchronous serial data communication or transmission. So, what is synchronous serial data communication or transmission? In synchronous serial communication, both transmitter and receiver uses same clock frequency for for their data transmission. But in case of asynchronous serial data communication, data transfer will take place at different frequencies, different clock frequencies. Different clocks are used for data transmission in serial manner, that is asynchronous communication. So while transferring this data, we two terms are very important, that is baud rate and RS-232 standards. Baud rate is nothing but number of bits which are transferred per second over the serial communication line or in between transmitter and receiver. But this baud rate is not always equal to bit rate, because baud rates are the number of baud rate is nothing but the number of bits are transferred per second. But in some cases or in all cases, we are transferring 10 bits for the serial communication. Now, these 10 bits are divided into three parts generally. 8 bits of data, that is main data which we will transfer over a serial line. Second, it will have one start bit, and third, it will have one stop bit. Start bit is always 0 and stop bit is always 1. So total 10 bits of data is transferred for one particular character or data type. Okay? So we are encoding this 8-bit data into 10 bits with one start bit, one stop bit, and 8 bits of data. So after transmission of start bit, LSB is always sent first and then MSB, and after that stop bit is always sent in 10-bit manner. Okay, so baud rate is always different from or mostly different from the bit rate. Okay, so in simple words, we can say that baud rates are nothing but the number of symbols which are transferred per second. Okay, generally baud rates are 2400, 4800, 9600, 19200. These are the baud rates which can be used for the data transfer by using RS-232 standards. Now, RS-232 standards are designed by Electronic Industries Association in 1960, before the invention of microcontroller. Okay, so these standards were designed for allowing the compatibility among the communication data equipment which were used for data transfer. In 1963, these standards were modified, and they had called they have been called RS-232A, RS-232B, RS-232C. These were issued in 1965 and in 1969 respectively. Today's RS-232 is most widely serial interface standard which is used for data transfer in between communication equipments, or generally we can say that in between personal computer and microcontrollers. Because these RS-232 standards were invented before the microcontrollers, okay, their voltage levels was different as compared to these TTL microcontroller devices. TTL logic family uses logic 0 and logic 1 signal as a logic 0 is nothing but 0 volt and logic 1 is nothing but 5 volt. So These standards are used for microcontrollers for data transfer, but these RS-232 standards were designed before the invention of microcontroller. These RS-232 standard uses different voltage levels for data transfer. For example, logic 1 is represented by -3 to -25 volt, and logic 0 is represented by +3 volt to 25 volt as a logic 0. Okay, so for this reason, to have communication between RS-232 and microcontroller, we have to use MAX232 IC for converting these TTL logic levels to RS-232 voltage levels, and vice versa. Like if we want to transfer data between microcontroller and RS-232 devices, or from RS-232 devices in between with microcontroller. Okay, so MAX232 IC is, all of you know that it is widely used for level converter or voltage converter for matching the voltage levels of TTL family and RS-232 family. Okay, this is the format of data that we can have for the data transmission, that is designed as a standard. Generally, parity bit is not used, but if we consider parity bit, these bits are divided into four parts: one start bit, data bits, parity bit, and stop bit. So this, whenever you whenever we go for 9-bit transmission, then this data bit is attached with the parity bit to avoid the error in between transmission and reception. So generally we uses 10 bits of data transfer, one start bit, 8 bits of data, and one stop bit. Along with this, parity bit is also sent if we are going for 9-bit data transfer. This is a standard. First it will go start bit, then LSB, at last MSB, then parity bit, and then stop bit. Okay. So for example, if you see the 8n dash 1, 8 dash n dash 1, that means what, 8 bits of data and one parity bit. And second is 7 data bits and 2 parity bits are used in some cases for data transfer. Okay. So to have connection in between RS-232 and microcontroller, DB9 connector is employed for making connection in between these two IO devices. So you can see this DB9 connector has 9 pins, which can be used for making connection between personal computer and microcontroller. Okay, so you can see these pins are there. Let us see this DB9 pin connector description. Okay, so pin number 3 is used for transmission. This is TXD pin. This is used for transmission of data, that is the serial data output function it carries out from this particular pin. Next pin is RxD pin. This is used for, as usual, it receives the data. This is serial data input. Okay, this is the function of this particular pin. Next, request to send. This is the third pin that is used for informing the modem that UART is ready. UART is nothing but universal asynchronous receiver transmitter. That UART is ready for exchanging the data. That is, this signal is sent from the microcontroller to modem that UART is ready to exchange the data. Next, clear to send. This is the indication given by modem to microcontroller or to personal computer or to data communication equipment that I am ready to send the data. That means clear to send. This modem will provide this particular signal to communication equipment devices. Next pin is DSR, data set ready. This tells the UART that modem is ready to establish a link. So link must be established after getting this particular signal. Next is SG pin is used for providing ground to the common circuit. This particular pin is used for providing ground. Next, first number pin is data carrier detect. Whenever modem detects a valid carrier in between two equipment devices, then this particular signal is raised and it establishes the connection in between data equipments, data communication equipments. Next pin is used for data terminals ready. This is this is the this is a signal which is used by modem to tell UART that UART is ready. Okay, that this means what, microcontroller will inform modem that UART is ready to establish link or to have communication link between data communication equipments. And this last pin RI, that is ring indicator, this particular pin is used for establishing the connection in between actually establishing the connection between data communication equipments. This particular pin goes active whenever modem detects a ringing signal from the PSTN, that is from communication equipment. So these 9 pins DB9 connector is used for making the or establishing the serial communication in between data communication equipments. Okay. In PIC microcontroller, PIC microcontroller supports both types of communication. It supports asynchronous mode of communication as well as it supports synchronous mode of communication. Okay. So this EUSART, that is Enhanced Universal Synchronous Asynchronous Receiver Transmitter Module, which can be configured in both communication modes, asynchronous mode, synchronous mode. Okay, it may be master, it may be slave, that can be configured in particular in this particular PIC microcontroller. 8051 supports only asynchronous mode of communication, but PIC microcontroller supports both modes of data transfer, asynchronous mode as well as synchronous mode. In asynchronous mode, different clock frequencies or different clocks are used, okay, or data transfer takes place at different clock frequencies. In synchronous mode of communication, data transfer takes place at same frequency. So that means what, we can say that transmitter and receiver is synchronized with the same clock frequency. For example, if we take Bluetooth, then we can establish connection between two mobiles by using Bluetooth or any other Bluetooth module. We can communicate with the mobile phone. So here we are synchronizing two mobile phones to have data transfer. So in this same way, synchronous communication takes place in between transmitter and receiver. Now, for the serial communication, two pins are given in the PIC microcontroller that belongs to port C. You can see RC6 is acting as a TXD and RC7 is acting as a RXD. Okay, so TXD and RXD, these two pins are given for serial communication. Data transmission will take place through TXD pin from the microcontroller to any data communication equipment or personal computer, and microcontroller will receive data through RxD pin from any communication data equipment or from personal computer. But if we need if we are going to use these pins, these particular three things we need to set up while communicating with the communication for while establishing communication between microcontroller and personal computer or any other data communication equipment. You can see here Serial peripheral enable bit or serial port enable bit is used, okay, for establishing the serial communication. After that, we must set this TXD pin as output pin and RXD pin as a input pin. So RC67 must be set to 1 and RC6 must be set to 0. This is the configuration that we must do while establishing a serial communication link in between microcontroller and personal computer. So this is the configuration for RC7 and this is the configuration for RC6. So we can write these values for making them output and input respectively for RC6 and RC7. Now, to control the operation of serial communication, these three registers which are used in USART register map, that is Universal Synchronous Asynchronous Receiver Transmitter, enhanced universal synchronous or asynchronous receiver transmitter. So these registers which are used for controlling the serial communication: transmit status and control register TXSTA, receive status and control register RCSTA. Transmission will take place by configuring this particular register, and the reception of data will be carried out by configuring this particular RCSTA register. Here in this third register we can set the baud rate. Baud rate control register, that is called as a baud con. Here we can set baud rates for desired baud rate for data transfer through serial communication. Okay. So these are the registers which are used for data transmission through serial communication: TXSTA, RCSTA, Broadcom resistor, and these two resistors are used for loading the data which will be transferred or which will be received through serial communication. If we are going for 16-bit, then these both registers are used. Okay. Otherwise, for 8-bit, this SPBRG register will be used. Okay. These two registers are used for baud rate generator, higher byte and lower byte. Okay. And actual data will be loaded inside this register, TX register, that is transmission register, and this is reception or receive register that will be used for receiving the data. Okay. So these two, again I will tell you, this particular serial port baud rate generator, this particular pin, this particular register and this SPBRG register is used for setting the baud rate with higher byte and lower byte. Okay. So we will see one by one in detail what these registers are and how to configure these registers. Okay. So first we will see transmit status and control register. This particular special function register is of 8-bit. Okay. And it has address of FAC. Okay, that belongs to ROM location. So RAM location. So this transmit status and control register uses 8 bits for configuring data transmission. Okay. So we will see one by one all bits of this particular register. First bit is CSRC, that is clock source selection of mode. Okay. So this particular bit is used for only synchronous communication. Okay. Whenever we want to do synchronous communication, synchronous serial data transfer, then we will use this particular bit. If we set for if we set this particular bit to 1, then we will our microcontroller will act as a master. If this particular bit is set to 0, then our microcontroller will act as a slave mode and will receive data. In master mode, it will transfer data to all data communication equipments, and from all data communication equipments it will receive data in slave mode. Okay. So next bit is TX9. Here we will set bit transmission mode for serial communication. Okay, if we write 1 to this particular bit, then 9 bit data transfer will takes place, and if we write 0 to this particular bit, then 8 bit selection mode or 8 bit mode of serial data transfer will be configured. Okay, generally while writing program we will select 8 bit data transfer by writing 0 to this particular bit. Okay, next bit is transmission enable bit. If we write 1 to this bit, then only transmission is enabled, otherwise transmission is disabled by using this particular bit. Synchronization. This particular bit is used for making mode of communication, selecting mode of communication, 1 for synchronous mode and 0 for asynchronous mode. Now next bit is send B. This is the bit which is used for sending the character bit. Okay, this particular bit is used only in asynchronous mode. It is not used in, sorry, it is only used in asynchronous mode. It is not used in synchronous mode. Okay, next is BRGH, high baud rate select bit. Okay, so if we are going for asynchronous communication, then only this particular bit will come into picture. If we write 1, then high speed baud rate will be selected, and if we write 0, then low speed baud rate will be selected. Okay, so after all doing this, what we have to do, we have to monitor this particular bit, TRMT, transmit shift register status bit. Okay, so whenever this bit is set to 1, then that means what, TSR is empty, that no data is in TSR register, transmit shift register, and 0, TSR bit is full. Okay, so we can monitor this particular bit for data transmission in serial form. TX9D, this 9 bit of transmit data. Okay, we are not going to use 9 bit data transfer mode, so we will ignore this particular bit, and later on we will study it. Okay, this is the receive status and control register, RSCR register, which is used for reception of data, configuration of configuration microcontroller in reception mode or receive mode by using this particular register. This this register is of 8 bit, okay, which uses 8 bits for configuring microcontroller serial protocol in reception mode. So next you can see here SPN again, this serial port enable bit. We must enable this serial port while receiving the data. If we write 1, then serial port is enabled, otherwise serial port is disabled. 9 bit, same way as a TX STR register we have seen. Okay, 9 bit transmission and 8 bit transmission. Sorry, in 9 bit transmission and 9 bit 8 bit transmission. Same way we can do this for reception of data. If we select 1, if we write 1 to this particular bit, then 9 bit data reception will be configured, and if we write 0, then 8 bit reception mode will be enabled. Okay, generally we will focus on only 8 bit reception of data. Okay, next is SREM, single receive enable bit. Okay, this particular bit is used for synchronous mode only, so master and slave. Okay, so enable single receive and disable single receive. Okay, next bit is CREN, continuous receive enable bit. What is the difference between these two bits? It will allow only data reception for once only. Okay, this particular bit will allow reception of data continuously. Okay, so this is continuous receive enable bit. When we write 1 to this particular bit, it will enable the receiver, and if we write 0, then it disables the receiver. Okay, That means what? We can continuously enable the receiver for reception of data by writing 1 to this particular bit. In this particular bit is used in both modes. Okay. In synchronous mode, this particular bit, single receive enable bit, can be enabled only in slave mode. Okay. In master mode, this particular bit is not usable. This particular bit is used in both cases. Okay. Next is address detect enable bit. Okay. This is used for detection of address. Okay. That enables interrupt and loads the receiver buffer when 8-bit mode is set. Okay. If we write 0 to this particular bit, then disables the address detection. Okay. It will allow data reception of 8 bits and 9 bit can be configured as a parity bit. Okay. So in asynchronous mode, 9-bit don't care condition is used if we are going for 8-bit transmission mode. Okay. This particular bit is used only in 9-bit data transfer on reception mode. Next, framing error bit. This is used for finding the error in the data reception. Okay. If this particular bit is 1, then that means framing error is there. If this particular bit is 0, that means what? No framing error is there. Same way overrun error bit. If this bit is set to 1, then overrun bit error occurred. You can assume that overrun error bit is occurred while the reception of data. Okay. If 0, then no error is there in the reception of data after receiving the data. And this is again 9 bits of ninth bit of reception that can be used for 9-bit data transfer or reception mode. Okay. Same way like transmission and status register. This is the baud rate control register that is used for selection of baud rate. Okay. So here you can see ABDOEF OVF. This is the auto baud acquisition rollover status bit. Okay. So when we write 1 to this particular bit, rollover of baud rate will take place. Okay. And no BRG rollover has occurred if giving 0. Okay. These are not used generally. Baud rate control register, you can see this is the receive operation idle status bit, receive data polarity select bit, clock data polarity select bit. Okay. So inversion is allowed in microcontroller, okay, for reception and transmission of data. Okay. So you can see these bits are important. BRG 16. Here 16-bit baud rate generator is used. In this case, both if we are going for 16-bit baud rate generator, that means what? 16 bits will be used for selection of baud rate. Otherwise, for 8-bit baud rate generator, this particular lower byte register is only used for selection of baud rate. These are registers which are used for selection of baud rate. That means baud rate calculated values can be loaded inside this particular registers. Okay. For configuring serial communication with particular desired baud rate. Okay. This bit is unimplemented. Wake up enable bit. This can be used in asynchronous mode. Okay. You can see if this particular bit is 1, that means what? USART will continue to sample RX pin and interrupt generated on falling edge. Bit cleared in the this can be cleared by this bit is cleared on the rising edge and falling on the falling edge. This will generate interrupt for the reception and transmission of data. And this auto baud detection enable bit, this is also used in asynchronous mode. Enable baud rate measurement on the next character requires reception of sync field 55H. Okay. This will discuss while writing program for this. Generally these particular bits are unused. Okay. These are the baud rate generator calculation formulas for selecting the values which are loaded inside the SPBRG H higher byte register and SPBRG lower byte register. Okay. So baud rate can be calculated like this: FOSC divided by 64 n plus 1 for these modes, synchronous, asynchronous. This is the formula for calculation of baud rate. But while calculating baud rate, you need to configure these particular bits. If 000 is written for these 3 bits, asynchronous mode is selected in 8 bit. Okay. If this bit is 1, then 16 bit asynchronous mode is selected. If this particular bit is 1, then synchronous mode of communication will be selected. If both bits are 1, then 16-bit synchronous mode is selected, and their formulas are this. So you have to remember that sync bit is very important, that is synchronous mode. If this bit is 0, that means asynchronous mode. If this bit is 1, that means synchronous mode. BRG16, if this bit is 0, that means 8 bits are used, okay, for selection of baud rate, and if this particular bit is 1, that means 16 bits will be used for selection of baud rate. Okay. So this can be configured in both synchronous and asynchronous mode of communication. This is a baud rate calculation. You can see for 20 megahertz frequency and baud rate of 9600, you can calculate the values like this. SPBRG with this 4 into 9600. Okay, this is a 20 megahertz frequency signal. 4 into 9600 minus 1. This will give the value this. Okay. Now actual error is there while calculating the baud rate. So we will approximate these values to next values. That is 0208. This will be loaded inside SPBRGH higher byte register and lower byte register. Okay. Formulas will remain same for calculation of these baud rates. Now to set up asynchronous transmission, okay, we need to follow these steps. Okay, what these steps are, we will discuss. Let's discuss these steps. Okay, first we have to initialize these particular registers which will be used for 16-bit baud rate generation mode. Okay, so we need to load appropriate values in these particular registers for selection of baud rate. Okay. After that, in second step, after loading these values for selection of baud rate, then we will enable this particular sync bit by writing 1 and 0 respectively for synchronous, asynchronous and synchronous mode of communication in SPBM serial port enable bit. This bit and along with this sync bit, we can enable serial port, okay, as well as we will select synchronous or asynchronous mode in second step. In third step, we have to set this particular transmission pin. Okay, if it is inverted, then TX-CKP bit should be set to 1. If we want to generate serial interrupt, okay, then we have to enable this TX-IE pin, IE bit. Okay, TX-IE bit is belongs to transmission interrupt enable bit. Okay, if we want to generate interrupt in serial mode after reception of data or transmission of data, then we need to select this particular RXIE and TXIE bits. Okay. In next step, if 9-bit transmission we are going to have, then we need to set this TX9 bit. Okay. Generally, we don't use this particular mode. We will go for 8-bit mode. Okay. In next step, enable the transmission by this setting the TX-EN bit. Okay. Along with this particular flag will be set to 1. Okay. This particular we will skip this and let load the data into transmission register for data transmission. We will load this particular 8 bits of data into this particular register. Okay. And again, if we want to have interrupt, if we want to generate the interrupt after transmission or reception of data, then we must enable this particular global interrupt enable bit and peripheral interrupt enable bit. This should be enabled to generate interrupt in serial mode. Okay, these bits belongs to int con register. Okay, same way, this we can do for asynchronous reception. Okay, these are the steps that we can follow. Okay, same steps are there, only instead of transmission here we need to use RCI, that is receive interrupt enable bit. Receive interrupt enable bit. For continuous reception we need to enable this bit. Continue receive enable bit. Okay, so all these steps are there, like transmission mode of asynchronous communication we can set. Okay, this is the circuit diagram that is used for having serial communication with the personal computer by using RS-232 standard and DB9 connector. DB9 connector is connected to serial port of personal computer, and these two pins are connected to microcontroller RC6 and RC7. You can see this is the RC6 is output pin, TXT pin, and RC7 is the input pin. Okay, that you can set for serial mode of communication. Okay, now at last, here we are going to perform one practical of serial communication. Okay, and this algorithm belongs to this particular practical, or it is written for this particular practical. Okay, we are going to have 8-bit data transmission. Okay, with one start bit, one stop bit, and we will transfer this data to computer. Okay, so for performing this particular steps we need to follow, that in first step we will write 16-bit value to these particular registers for selecting baud rate. 9600 is the most generally widely used baud rate. Okay, for that we need to calculate the values, and that will be loaded inside these registers to select the border. Okay, the calculation of these values we will see while studying the practical. Okay, next we need to configure this particular RC6 pin as a output pin, which is TXD pin, and RC7 as a input pin, which is RXD pin of the PIC microcontroller. Then here we will use 8-bit mode only, so we will write here 8-bit mode in Broadcom register. Okay, so BRG mode is of 8-bit, and then we will enable asynchronous mode by writing 0 to this particular bit. Okay, in TXSTA register. Then we will enable serial port by writing this particular bit to 1. Okay, SP serial port enable bit. Okay, in RCSTA register serial port is enabled. Then enable the transmission by setting TXEN bit in TXSTA register. This will enable the transmission, otherwise transmission will be disabled. So these two bits must be set to 1 to enable serial communication. Okay, in simple words, serial port enable bit and transmission enable bit. Then we will wait for TRMT bit. Okay, in TXSTA register. Okay, so load whenever this particular bit raised to 1, then we need to load this data into TXREG, that is transmission register is empty, that is showing the transmission register is empty. After doing this configuration and loading the data inside TX register, we need to repeat the step 6. That means what? This particular bit is enabled continuously, so to transmit the data completely, that is message will get transmitted. Okay. Now about reception, we need to receive data continuously. Then we need to set this particular bit, CREN bit, continuous receive enable bit, in RCSTA register, that we have recently discussed, just before discussed in RCSTA register. Okay. Then here we will monitor this TX and RC, that is TX and RC flags for transmission and reception of data. Okay. Then after reception of complete 8-bit data, we will read this particular register, and we can copy this particular data inside microcontroller. Okay. And if we want continuous transmission and reception, we will continuously follow these particular steps. Okay. So this is the algorithm for transmission and reception of data from the personal computer, or from microcontroller to personal computer, or from personal computer to microcontroller. Okay, these steps, algorithm steps we need to follow to have serial communication in between microcontroller and personal computer. Okay, this is all about serial communication. In the next session, we will discuss program, okay, and calculation of baud rate for transmission and reception of data. Thank you.